Hey friends, this is Vidhan. Welcome you to my channel. Today we will see voltage divider rule. That means we will learn to find out voltage drop across a resistor. Now the first condition for the voltage drop rule or the voltage divider rule to be applicable is that the resistors in the circuit must be in series. Because only when the resistors are in series they can drop voltage. But if they are in parallel they cannot drop voltage. And the circuit which is having resistors in series is called voltage divider circuit. That means voltage divider rule is applicable for voltage divider circuit. And what is the voltage divider circuit? In which the resistors are in series. Now one thing, why have I drawn these two voltage divider circuits? This is a voltage divider circuit because resistors are in series, and this is also one voltage divider circuit because resistors are in series. They are also called voltage divider network. Now one thing, why have I drawn two same voltage divider network? This is because of the reason that I will find out voltage drop by using two methods. I want to find voltage drop across R1, R2, and for here also R1 voltage drop across R2. And I will use two methods to find out the voltage drop across the resistors. The first method is by using Ohm's law. There is a basic question about Ohm's law. What is Ohm's law and what is this voltage is actually in the Ohm's law? Let me tell you that this voltage you see in the Ohm's law is the amount of voltage drop across the resistor R when there is a current I in the circuit. That means Ohm's law is also a voltage drop law. I should write here R. That means voltage drop across R is equal to I into R. So what is the voltage drop across R1 if we want to use Ohm's law as the voltage drop law? So VR1 is equal to I into R1. What is the voltage drop across R2? By using Ohm's law as the voltage drop law, VR2 is equal to I into R2. So this is one. And the second method is standard voltage drop formula, and standard voltage drop formula gives us the voltage drop across any resistance R is equal to EMF. V is the EMF, this is EMF, into this resistance, the same resistance that I want to find the voltage drop across, by all the resistances added, that means R equivalent. So this is another formula. So we have two formulae for finding the voltage drop across a resistor. Either you use the Ohm's law as the voltage drop formula or you use the standard voltage drop formula. So from here, what is the voltage drop across R1 using this? It is VR1 is equals to V into R1 by R1 plus R2. And what is the voltage drop across R2? It is VR2 is equals to V into R2 by R1 plus R2. Now one thing, a question arises, if we have two methods, which is the easier one and which is more convenient? In that case, let me tell you that this is easier one and this is more frequently used than this. What is the reason? The reason is that, see here, if you want to find the voltage drop across R, first of all you must know what is the current in the circuit. You have to calculate the current in the circuit and then only you can use Ohm's law as the voltage drop formula. But here you notice that you don't need to have the current. Even if there is a current, obviously there is a current when I give a voltage and resistors, and since this and this circuit are same circuits, so the current in this circuit is equal to the current in this circuit. But for this circuit we don't need to find the current, and yet we are able to find out the voltage drop across any resistance. So here we are able to find voltage drop across R1, here R2, without the current, but here I have to find out the current. So this is the advantage for this. voltage drop formula, and that is why we frequently use this, and this is what we used in class 9 or 10, but it is also valid. Now we let me take a practical circuit that I also discussed about. Plus minus, this is 12 volt, 2 ohm, 4 ohm. Now let me take first of all Ohm's law as the voltage drop formula. What is the voltage drop across 2 ohm? It is I into R, V equal to I into R, I into R, R is 2. I just told you that I must first of all calculate current for using the Ohm law as the voltage drop formula. So I am bound to calculate the current. I is equal to V by R equivalent, V by R equivalent. So V is 12 by 6, 2 plus 4 is 6, 2 ampere. So in the whole circuit there is 2 ampere current. Current is always a single current in the whole circuit, you must remember it. Now this is 2 into 2, 4 volt. And what is the voltage drop across this? The voltage drop is, we will use the Ohm's law as the voltage drop formula. That means I into R, V equal to I into R, and this V is voltage drop. So I into R, I is 2 into 4, 8 volt. So across this resistance we have 8 volt drop, and across this resistance we have 2 volt drop. So initially we had 12 volt, sorry, 4 volt drop here. Initially we had 12 volt, 4 volt dropped, so now we have 8 volt, and here 8 volt dropped, so we are left with 0 volt, because this resistor will fill a voltage of 8 volt, and this dropped 8 volt, so what we are left with? 0 volt. So 12, 8, then 0. And if you take a terminal from this point, what is the voltage at this point? It is 8 volt. And if you take out a terminal from this point, what is the voltage at this point? It is 0 volt. You don't confuse that the source is 12 volt, then it would be 12 volt, etc. No, because there has been a drop, so we have to subtract this drop from our EMF to get the voltage at this point. So this is one thing. And one thing, that add all the voltage drops, 4 volt and then 8 volt, the total is 12 volt. That means the voltage that we have provided. So it is also a law that the voltage that you have provided in a voltage divider circuit will completely drop itself. So see here that this voltage divider circuit has completely dropped this 12 volt, and this is one more law. This is called Kirchhoff's voltage law. What is Kirchhoff's voltage law? That all the voltage drops across a voltage divider circuit added should be equal to the EMF provided. Now this is something more that you have to remember along with this. Now let me tell you one thing, that even if I use 3 resistors or 4 resistors, this 12 volt will be dropped, but in a shared manner. Here 2 resistors together have dropped total of 12 volt. If there will be 3 resistors, these 3 resistors will together drop the total of 12 volt. Now let me show you the same circuit. I'll show you the same circuit but with now let me show you the same circuit, but I will use the standard voltage drop formula to find out the voltage drops. Two ohm, 4 ohm. Now what is the voltage drop across this? We know this is 4 volt. The voltage drop across 2 ohm is 4 volt, but I will use this formula. So voltage drop across 2 ohm is 12 into 2 by 2 plus 4, 2 by 6, so 4 volt. Now again we got 4 volt. So here it was 12 volt, 4 volt dropped, so what we are left with? 8 volt. Now what is the voltage drop across this resistor? 12 into 4 by 2 plus 4, 4 by 6, 8 volt. So 8 volt dropped across this. Now already for this resistance there was only 8 volt and this dropped, so finally it is 0. And again 4 volt plus 8 volt we say equal to 12 volt, and it shows that either you use this formula as the voltage drop formula or you use Ohm's law as the voltage drop formula, both are equally valid, except that for using the Ohm's law as the voltage drop formula, first of all you had to calculate the current, but now I have not calculated the current, but yet I was able to find the voltage drop across 2 ohm and voltage drop across 4 ohm. So this is what I had to show you. Now the same circuit I will draw in a practical way. This is the voltage divider circuit and we have found the voltage drops across the resistors, but how this is practically used and you come across in practicality. So let me show you that. I will again draw the same circuit, but in a different fashion. 2 ohm, 4 ohm. Tell me, have I drawn and it is 12 volt? Is this circuit any different from this circuit? No. This circuit is exactly same as this circuit. Do you see? Because 2 ohm 4 ohm resistances are in series, 2 ohm 4 ohm and they are in series, and 12 volt supply, and this is a closed loop and this is actually also closed loop because these two terminals are connected since both are grounded. So this circuit is same as this circuit, and from here I take out a terminal and feed it to an operational amplifier, plus minus V out, and suppose the negative terminal is grounded. Then you may be asked, one may ask you, what is the voltage at this point? And this is the question, this is the practical use of the voltage divider circuit. You may be given a voltage divider circuit of this kind and you may be asked what is the voltage at this point. Now the voltage at this point is actually voltage at this point. And what is the voltage at this point? We know across 2 ohm there is a voltage drop of 4 ohm. 4 ohm dropped. So 12 volt was there, 4 volt dropped. At this point what is the voltage? 8 volt. So at all these points up to this point 8 volt. If I take a terminal from this point, then this point will also be of 8 volt, and this is the use. This kind of thing is asked in problems relating to operational amplifier. Voltage divider circuit is created in this fashion, and then a terminal of this is fed to the operational amplifier, and you are asked what is the voltage at this point. So you have to remember it. This is the practicality of voltage divider circuit. Okay, now one more thing, that we will use the three resistors now. 2 ohm, 4 ohm and 6 ohm. We again use 12 volt. Actually we are checking that for for the circuit having two resistances, the 12 volt completely dropped. If we take three resistances, will the 12 volt completely drop itself? This is what we want to check. So the voltage drop across this, we will use the standard voltage drop formula, and this is voltage drop across 2 ohm is EMF into, that means 12 into 2 by 2 plus 4 plus 6, 12 into 2 by 12, 2 volt. Now what is the voltage drop across this resistance? So voltage drop across 6 ohm is 12 into 6 by 2 plus 4 plus 6. 12 into 6 by 12. 6 volt. And what is the voltage drop across this? 12 into 4 by 2 plus 4 plus 6, and this is 4 volt. That means the voltage drop across this is 6 volt, voltage drop across this is 4 volt, and the voltage drop across this is 2 volt. So initially it was 12 volt, 2 volt dropped, so at this point it is only 10 volt. So if you take out any terminal, it will have a 10 volt, and suppose if you feed it to any operational amplifier, then this voltage will be 10 volt by using the voltage division or the voltage drop, because 12 volt was there, 2 dropped, so it is 10 volt point, and here 4 dropped, so at these points what is the voltage? 6 volt, and here 6 volt dropped, so complete drop is there, so 0 we are having. Now again you see that voltage drop 2 volt, here the voltage drop is 4 volt. If we add, and here 6 volt, all they add to make 12. Again our complete voltage that we have provided dropped across all the resistors. That means it doesn't matter whether you use 2 resistors or 3 resistors or 4 resistors, the voltage that you provide must drop completely. Finally it will become 0. Yes, one thing is there, when you increase the resistors, the current will be lesser. In this case we saw that for this circuit there is a current, and the current was 2 ampere. If you calculate, the current is 2 ampere, but for this circuit if you calculate, the current is V by R, that means 12 by 2 plus 4 plus 6, 12, 1 ampere. That means current is less and less when you increase the resistance higher and higher. You make the resistance higher and higher, the current becomes lesser and lesser. But one thing is that the voltage completely drops. So for 2 resistance circuit, voltage completely drops. For 3 resistance circuit, voltage completely drops. For 4 resistance circuit, voltage completely drops. But it's that current for 1 resistance circuit is lesser, current for 2 resistance circuit is higher, more lesser, and for 3, when you increase the resistance, the current becomes lesser and lesser, but the voltage finally drops. So this is what you have to remember. So for that, let us take a circuit that is having only one resistance and very low resistance, 2 ohm, and again we use the 12 volt because it is working as a standard voltage for us, because all the circuits I have taken for with 12 volt. Now what is the voltage drop? Let me take the Ohm's law as the voltage drop formula. That means voltage drop is V is equals to I into R, and we know that we have to find the current first, otherwise we are not able to use the voltage drop as the voltage Ohm's law as the voltage drop formula. So current is equal to V by R, that means 12 by 2, 6 ampere. Current is 6 ampere, then what is the voltage drop? 6 into 2, 12. So see here that we had 12 volt supply. Even if we had a very little resistor of resistance value, very little resistance value, but even this little resistance dropped all my 12 volt completely. That means if here we have 12 volt, then at this point we have 0 volt. So whatever resistance it is in the circuit, be it anything, it will completely drop our given voltage, but current will be different for the circuits. Current matters, that if the resistance is higher, current will be lower, if the resistance is lower, current will be higher, but whatever voltage you provide to the circuit, that will be completely dropped, and if you provide 100 volt, it will be completely dropped through this 2 ohm. This is the law. Now there also a question that arises in this regard, that what if we provide the same 12 volt but there is no resistance? Let us suppose there is no resistance, even the internal resistance is not there. If we suppose even there is no internal resistance, R is 0, and we provide 12 volt, then what is the voltage drop? It looks like that at this point it will be 12 volt, at this point it will be 12 volt, at all the points it will be 12 and voltage will not drop. It looks like that. But what I have told you so far, I have told you that the voltage that you provide in a closed circuit must drop itself. That means the voltage now 12 volt, it must drop itself even if when there is no resistance. Actually what happens is, in this case, if you want to find, first of all we want to use the voltage drop formula. Ohm's law is the voltage drop formula. So first of all find the current, and current is what? V by R, and R is 0. 12 by 0, it is what? It is undefined. So current is undefined, but 12 volt will completely drop itself. That means the voltage drop I into R, and it is finally equal to 12. But since we don't know what is the current, so this kind of condition is generally not used. Actually it is not practically possible, because always there is a resistance. Even if the outside resistance is 0, but there is always a little, at least little internal resistance. But now this case, since I is undeterministic, we cannot determine what is I, so this kind of concept is now not valid. Mathematically this is the limit. This is a limit to our mathematics to use or to see it in physical terms. So we cannot find out anything here. So we have to find that current will be infinite, current will be very huge, since 12 volt is there and it has to drop. This is possible, and this is always happens. This is what always happens. This will drop itself completely across the circuit even if resistance is 0. So the current that it will make, it will be huge current, and therefore generally if you close loop this kind of a battery without any resistance, if you make it a closed, then generally the wire burns, because it will be a huge current, and current we cannot define, mathematically we cannot define, and it will burn out. But what is happening all the time, that the voltages that we provide are getting dropped completely. For 2 also, for 3, for 3 resistors it is getting dropped. Then we saw for 2 resistors the voltage is getting dropped. Even for 1 resistor the voltage is completely getting dropped and making a current. And for 0 resistance also the voltage will get dropped completely and will make a current. But now the current is undefined. It is a mathematical limit, we cannot define. But voltage will get dropped and it will be a huge current, but here it will be a little less current and it will be a little more less current. Understood? So this is all about the voltage divider formula, and we will see if there is anything in our next video. Thank you.